Now we can see how to do the concave mirror experiment. The aim of the experiment is to determine the focal length of the given concave mirror. Here we are using 4 methods for finding the focal length. The first one is distant object method, second one UV method, third one UV graph, and fourth one is 1 by U, 1 by V graph. The apparatus required are concave mirror, a screen, a source of light, and meter scale, etc. Now we can go through the principle used. Okay, for distant object method, we have to measure the distance between the screen and the mirror. So that will be the focal length. And for UV method, we have to use F is equal to UV by U plus V for calculating the focal length. Here U is the object distance, that is the distance between the object and the mirror, and V is the image distance, that is the distance between the image and the mirror. Okay, and by using UV graph, we have to use the equation OA plus OB by 4. So here OA and OB are the coordinates at the point where U is equal to V. And from 1 by U, 1 by V graph, we have to use F is equal to 2 by OA plus OB. Here OA and OB are the intercepts on the X and Y axis respectively. So these 4 are the principle used, and for exam you will be getting only 2 questions from this. So which one is asked, that only you have to write as principle. Now we have to discuss the distant object method. Here we can find the focal length of the concave mirror by using distant object method. Okay, for that first of all we have to mount the concave mirror on a stand, and then the mirror we have to face a distant object or a distant scenery. After that we will place a screen in front of it. Okay, just like this, and we will adjust the position of the screen in order to get a well defined image. And the distance between the image and the pole of the mirror we have to measure. So that will be the focal length of the concave mirror. Okay, so whenever we are taking the measurement, make sure that we are taking the measurement from the center of the mirror to the center of the screen. Okay, and we can repeat the experiment for getting the mean focal length. Okay. Now we have to write down the readings in our tabular column. For that we have only 3 columns. In the first column we have trial number, and in the second column we have focal length. So that we can write down this. So no need of calculations here. Directly we can write the measured focal length there. And then we will repeat the experiment and then find the mean. So that will be the mean focal length in the third column. Here the ray diagram is also very important. You have to draw the ray diagram like this. Here we can see the image, that is IM. Here we can discuss another method for calculating the focal length of concave mirror, that is UV method. In UV method we will keep the concave mirror on a stand, and then it will be keeping in front of a candle. Okay, and we have to keep a particular distance that should be greater than the focal length of the concave mirror, because we have already calculated the focal length of concave mirror by using distant object method. Okay, then we have to keep the screen in front of the mirror, and the position of the screen we have to adjust for getting a clear image. Here we can see the arrangement. So for getting the first reading, we will keep the candle and the concave mirror at a particular position, and by keeping it as constant we will move the screen for getting a clear image. So in this diagram we can see the clear image, that means the inverted image of the light. Okay, so that we have to stop moving the screen, and then we can take the reading. Here for taking the measurement we have to take both the measurements, that is U and V, from the concave mirror itself. Okay, so the distance between the concave mirror and the candle will be U, that is the object distance, and the distance between the mirror and the screen will be V, that is the image distance. So whenever we are measuring, we have to make sure that we are taking the readings from the center of the stand to the center of the candle. Okay, so that will be the same. And in the case of screen also, we have to keep at the center of the screen to the center of the mirror. Okay, then only we will get the proper values. And the
After
image should
the
be
reading, we can
very
the
clear
experiment
as
code
shown
different
values of view, that is the object distance. So that we have to change the object distance, that is the distance between the mirror and the object, that is the candle, and then the corresponding values of V, that is the image distance we have to find. So here we can see another set of reading and then repeat it for minimum 6 set of readings. Whenever you are writing the theory, it is important to draw the ray diagram. So this is for the UV method, and here you have to mark U and V, and we have to put the arrow marks of these rays. Okay. Now we can go to the calculation part. Here, after getting the values of U and V, we can calculate the focal length. So F is equal to UV by U plus V. So that we can substitute the values of U and V. Then we can find the focal length. So in the same way, we will repeat the calculation for different values of U and V. Then find the mean of focal length. Here in the last two columns, we can see 1 by U and 1 by V, so that we can use for drawing the graph. Okay, so that also you have to calculate. Now we can go through the third method for calculating the focal length, that is UV graph. So we can see in UV graph, we are taking U along x-axis and V along y-axis. Here, whenever we are taking the scale, we have to make sure that we are taking the same scale for U and V. Then only we will get a proper graph. So after joining the graph, we have to draw a bisector of the angle XOY, and it should be meeting at C. Okay, and make sure that the angle is 45 degree each. Okay. After that, you have to draw BC and AC, and also measure the values of OA and OB. Then we can calculate the focal length by using the equation OA plus OB by 4. So that will be the focal length of the concave mirror. Now we can go through the last method, that is 1 by U, 1 by V graph. So here we can see the graph is a straight line, and we have to take 1 by U along x-axis and 1 by V along y-axis. Now here we have to measure OA and OB. Then we can calculate the focal length as F is equal to 2 by OA plus OB. After doing the experiment, we have to write down the result. So here we have discussed the 4 methods for calculating focal length, right? So that we have to write all the 4 results. So here focal length of the concave mirror. First one is by distant object method, and the second by UV method from UV graph, and 1 by U, 1 by V graph. So that values you can write there. Now we are going to conclude the video. If you like my video, please like, share and subscribe. Thanks for watching.